The Oujiang North Estuary Bridge is located in Wenzhou, China, which is the last link of the National Expressway G15W3. The bridge adopts a double-deck structure, which includes a two-way 6-lane arranged on the upper deck mainly serving transit traffic, and a two-way 6-lane free road on the lower deck serving local residents, and activating the development of local economy. The Oujiang North Estuary Bridge is China's first bridge built according to this mode, and serves as a model for integrating local and transit traffic. This bridge, which has a main span of to multiply 800 meters, is the first rigid mid-tower multi-tower suspension bridge in the world. This innovative structure significantly improves the bridge's overall rigidity and wind resistance performance, while saving on engineering costs through the use of a rigid middle tower and high-friction saddle. This bridge is located in the estuary of the Oujiang River, south of Wenzhou Airport. The height of the tower is strictly limited below 154 meters, but the height for navigation is 53.5 meters. There are also technical challenges such as high flow rate of tides, poor geological conditions, and frequent typhoons. Firstly, due to the height restriction above the bridge, and the space limitation below for the navigation, only a 3-tower suspension bridge structure can be selected. Secondly, to facilitate the development and utilization of the shoreline S on both sides of the bridge, the side towers need to be located behind the terminal line of the piers. Therefore, the design adopts a to multiply 800 meters 3-tower suspension bridge scheme. By skillfully utilizing the characteristics of the double-deck structure, the main cable in the middle span passes through the upper deck, and the suspension points are located on the lower deck, achieving a 1/10 ratio of cable sag to span length. This reduces the tension in the main cable and improves the economic efficiency of the bridge. This kind of arrangement is the first in the world. Due to the high requirements for wind resistance and corrosion prevention, concrete towers were chosen instead of steel towers, which provide 30% higher wind stability and greatly reduce maintenance costs, resulting in a cost savings of 130 million yuan compared to steel towers. The final design utilizes for column reinforced concrete-shaped towers. The concrete tower scheme presents higher requirements for anti-slip properties of the main cable saddle. A novel design was proposed to increase the frictional force between the main cable and saddle by introducing a vertical friction plate inside the saddle. This friction plate doubled the nominal coefficient of friction than the conventional saddle, considering that the middle tower foundation of the bridge is only 45 m away from the side line of the main channel. The middle tower foundation adopts the open caisson foundation, relying on the gravel layer as the bearing stratum. The bridge adopts a double-deck steel truss structure with a height of 12.5 meters, and the standard distance between two sections is 10 meters. Its two main trusses has a space of 36.2 meters. A large number of new technologies and equipment were used in the construction of this bridge, representing the latest construction technology of long-span suspension bridge. This bridge adopts the rigid middle tower. The horizontal longitudinal stiffness of the middle tower is up to 221.6 meganewton per meter, leading to the 113.9 ms critical flutter wind speed and 606 span deflection ratio, which is much higher than that of other 3-tower suspension bridges that have been constructed. A series of breakthroughs has been made during this bridge's construction, including the mechanisms of cable sliding, the structural type and production technology of the new type of cable saddle. Its nominal coefficient of friction can reach 0.3, which is very beneficial for promoting the application of multi-tower suspension bridges. To address the manufacturing difficulties of the fully vertical friction plate cable saddle, the first narrow gap welding robot has been developed, and the intelligent deep groove cable strand entering robot has been developed. to address the difficulty and poor quality of the deep groove cable strand during entering the saddle. These two types of robots prioritize human needs and significantly reduce labor intensity. A new technique called standard ruler cable stay installation method is proposed to address the problem of not being able to adjust cable stays during the day using the PPWS method. High precision installation of the main cable strands has been achieved for all-weather hoisting, setting a new record of an average of 9 cable strands installed per day, due to the difficulty of erecting special beam segments in the mid-span. A new relay lifting method of cable-mounted crane and split lifting equipment has been adopted to solve this problem. The construction of this bridge has very small impact on waterways and ecology, as well as has high construction efficiency and strong economic feasibility. The main cable sets a graceful curve as the main theme, and it is complemented by the vertically distributed suspender cables and robust steel truss, embodying the perfect combination of strength and beauty. The crossbeam of the bridge tower is shaped as an arch, which originally inspired from the architectural lintel elements of Wenzhou's opening period, symbolizing the gate of Oujiang River, the open mind of the local people, and the vibrant private economy, welcoming friends from all over the world to Wenzhou. The construction starts from January 2017 to May 2022. During this period, the project has passed the ordeal of Typhoon Hagupit and the 3-year COVID-19 pandemic. Relying on this project, 46 papers were published and 12 patents were obtained. This new bridge type has great promotional value and can be applied to more multi-tower suspension bridges with larger spans, and is very suitable for wide water areas, since it increases the overall stiffness of multi-tower suspension bridges. Railway or road railway combined bridges can also use this type of bridge. After 10 years of research and 5 years of construction, Oujiang North Estuary Bridge embodies the latest technology of multi-tower suspension bridge. The bridge is very suitable for the IABC Outstanding Structure Award.